Day 50 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. I'm glad you guys are still here with me doing these LeetCode problems every day, guys, because we're still trying to learn and we're still learning. And we made it to day 50. A lot of people are not going to make it this far. A lot of people can't even stay consistent for something for a week, let alone 2 weeks, let alone 50 days. So that is something to be happy about. Even though, just remember, we're not even 2 months in, so we still have a lot more learning to go. We have a lot more things we need to learn along the way. However, if you made it to day 50, that's something you should be happy about. And it's like halfway to 100. So I feel like that's a good number to be, that's a good number to be happy about. Even though it hasn't been that long, we're halfway to 100. But remember, we're doing LeetCode 75, so we have at least 25 more days to finish the LeetCode 75. Then after that, I'm going to do a few easy problems. And then after we do those easy problems, we got to do the LeetCode 100-day challenge. So when you think about it like that, 50 days is not that much. It may not be that much to get excited about, but if you know you have a problem staying consistent and you know you're trying to work on your discipline and make yourself more disciplined, then if you've done something for 50 days, guys, you should be happy about that, because that's a start, and that's all it's about, is starting. You have to start somewhere. You have to crawl before you can walk. Every 10,000-mile journey starts with the first step. So yeah, we made it this far. I hope you guys continue to keep learning, because we're not going anywhere. We're going to keep doing these LeetCode problems every day until we get good at it, until we learn and understand as much as it is to learn about these data structures and algorithms, or at least as much as LeetCode is able to teach us. We're trying to learn it all, guys. So I'm glad you're still here. It's day 50. We're not stopping anytime soon, but it's a good landmark, good milestone to make it to, and should pat yourselves on the back if you made it this far. Now, with that being said, guys, you already know what I need you to do. I need you to take a mouse, bring it right over here and click that subscribe button. And after you click that subscribe button, go ahead and hit the like button. And after you hit the like button, go ahead and drop a bank emoji in the comments. All of my bankers out there, I need you to go find that bank emoji and drop it in the comments so we could build this community. And this is just a small community and a bigger Swift community. And the overall goal is to build this Swift community and bring awareness to Swift so people could learn Swift and we could get Swift popping out here in the world, guys. So go ahead and help me out. We're trying to run this engagement up, but I appreciate the help. Now, for the main attraction, the part you guys have all been waiting for, we're about to start the question. And today we have question number 1448, count good nodes in a binary tree. The difficulty level is medium, but if you guys have been paying attention to this channel, you know we're not going to let the difficulty level deter us from completing these problems, and we're still going to keep the solution as easy and simple to understand as possible, because we're all learning here, and part of learning is understanding the code that you've written. Once you understand enough code, you'll be able to, and memorize enough code, you'll be able to take bits and pieces of each code that you understand and memorize and put it all together and write your own code. So that's important too, to understand the code. It's important to understand the code and not just type it out and you don't know what you're typing. So let's read the question. It says, given a binary tree root, a node X in the tree is named good if the path from root to X, there are no nodes with a value greater than X. Return the number of good nodes in the binary tree. So per usual, that's a question's a little vague. It might be hard to understand without looking at the example. So that's what we're going to do. We're going to come down here to example 1 and look at the example. This says the input, we have the root and the list of nodes. The output is 4. The explanation says nodes in blue are good. Root node 3 is always a good node. Node 4, 3 or 4 is the maximum value in the path starting from the root. Node 5, 3, 4, and 5 is the maximum. So 5 is the maximum value in the path. Node 3, 3, 1, or 3 is the maximum value in the path. So let's look at this example and break it down so it can make some more sense to you guys, and you could really understand what it is that we're trying to do. So we're starting at root 3. They say the root node is always good. In this case, it's 3. So that's a good node. We're going to start right there. Then we come down here to 4. 4 is the greatest number between 3 and 4. 4 is greater than 3, so it's a good node. In its path from 3 to 4, 4 is greater than 3, so it's a good node. Then we come down here to 5. 5 is greater than 4, and then it's the maximum value in its path. So from the whole path from 3 to 4 to 5, 5 is the maximum value. So it's a good node. So, but when you come down here, you realize 1 is less than 4. So it's a bad node. It's less than 4. Same thing on the left side. We're going to check the left side. You come down here, 1 is less than 3 already. So we're already starting off wrong, starting on a bad tip. This is not a good node right here. But we come down one more, and the next node is 3. 3 is greater than 1, and 3 is also equal to the root node 3. So it falls into the category of it's the maximum value in the path, which is 3, because it's tied to the root node 3. So basically what we're doing, we want to check to see if the node is greater than the nodes that come before it. If it's not, it's a bad node, or it's not a good. I'm not gonna call it a bad node. Just not gonna say it's just not a good node. It could be okay, an all right node. It doesn't have to be bad, but it's not a good node. So let's look at example 2. You come down here, and this output is 3. So in this output node 2, 3, 3, 2 is not good because 3 is higher than it. So when you come down here, 3 and 3 is the same. It's equal. So it's the same number, so it's a good node. Then you come down here, 4 is greater than 3, so it's a good node as well. And it's the greatest number in its path, so it's a good node. It checks out. But when you come down here, 2 is less than 3, so it's not a good node. It's not greater than. We need it to be greater than, and it's less than, so it's not a good node. Then we come down here, example 3 is just 1. Node, the output is 1. Root is considered as good. So the root is always good, which means if there's only one node, that means there's only the one node is the root, and that's going to always be good. So let's figure out how we're going to solve this. First thing we are going to do is we're going to create a helper function. If you guys watched the last video, we had to create a helper function there as well. But now, first thing we're going to do, create a helper function, and we are going to say this function we're going to call good count. And this is going to have, first it's going to have a root, which is going to be a tree node. Excuse me. Don't forget the question mark after tree node. Then we're just going to have another parameter called greatest, and that is going to be an integer. And we're going to return another integer. Then first thing we're going to say guard let root, else we're going to return 0. Then we're going to come down here, we're going to declare a variable, and that variable is going to be called is good. And we are going to set that equal to root.val is greater than, so we're going to check to see if the, excuse me, I forgot the T, but we're going to check to see if the root.val is greater or equal to greatest. Then we're going to put the question mark, because if it is greater or equal to greatest, we're going to add 1, or else we're going to add, we'll add 0. Then we're going to come down here, we're going to say declare another variable called next greatest, and that is going to be equal to the max of the root.val or greatest. Excuse me. Then we're going to come down here and we are going to say, or we are going to return, is good plus good count And this good count is coming from the name of the function. So now we have to enter the parameters, and the parameters, first it's going to be a tree node. That first tree node is going to be root dot left, and then we're going to say comma next greatest. Then we're going to come over here and we're going to do the same thing for the right side, and we're going to say good count. Then we're going to create the parameters, and this time it's going to be root dot right, comma next greatest. Right, so that's our helper function. Then we're going to come up here, we're going to call the helper function, but first we're going to do the same thing that we did down there, and we're going to say let root, guard let root, else return 0. Then after we do that, we're going to call the function by saying, by saying return good count. Then we're going to enter the parameters root, comma, negative int dot max. And what negative int dot max is, it's just the smallest number possible that your computer will allow. Whatever that number may be, that's the smallest one possible. That's what negative int dot max. If we took this negative sign away, then it would be, and it was just int dot max, then it would be the greatest number that's possible that your computer would allow. But in this case, we want the smallest possible number, and that's why we say negative int dot max. Right? Then that's all she wrote. That's all we needed, guys. So let's run it, see what happens. Okay, guys, it's accepted, so let's submit it and see what that time is looking like. Boom! 193 milliseconds beats 50.93% of users with Swift, guys. So there it is. There's the solution. We're going to get those numbers up, but at the same time, I want the solutions to be as easy to understand because we're all learning. There are faster solutions, but they're going to be harder to understand. And like I said, we're only on day 50. We don't need to put the cart before the horse and start doing things that we have no idea what we're doing. This is good I think this is a good way to understand the logic, and that's very important when doing LeetCode. You need to understand the logic and how programmers think. And I think this is a good solution that'll help you understand the logic and understand what programmers are thinking when this code is being written. So with that being said, guys, I will see you guys tomorrow for day 51. Another day, another LeetCode problem. Peace.